Now a stack can be implemented using an array or a linked list. And I've already explained you this in my data structure tutorial 2, and in this video I will explain you how to implement stack using a linked list. Now in case of a stack, an element can only be inserted from the top and an element can only be deleted from the top. An element can be an integer value, float, character, etc. So in a stack, insertion and deletion can only take place from the top. Now there is a variable called top which is associated with a stack, and when the stack is empty then the value of top is -1 in case of an array, but here we are talking about linked list. So when the stack is empty then the value of top is equal to null, and null you know means empty or nothing. So if the value of top equals to null then it means stack is empty, and this stack empty condition is also called stack underflow. Now you must have seen that in a linked list there is always a pointer variable generally named start that stores the address of the first node, and if that pointer variable is equal to null then it means linked list is empty. So here that pointer variable is top. Now to implement stack using a linked list, we have to make a linked list behave like a stack. And how can we make a linked list behave like a stack? We can do that by following a property of a stack, and that property of a stack is that elements can be inserted or deleted only from the top. So initially this list was empty, then I added a new node in this linked list, and the node has been added from the top. Now top has the address of this node. Suppose the address of this node is 1002. So top will store the address of this node, and suppose this node is storing some integer value, let's say 25. Then you can imagine this whole thing as one element in the stack. Now if I insert another node in this linked list, then it should be inserted from the top. The new node should be added at the beginning of the linked list. So I have added a new node at the beginning of this list, and now top should store the address of this node. Suppose the address of this node is 1005, and suppose this node is storing 55 as an element. So you can imagine this whole thing as two elements in the stack and a new element added from the top. Now again I added a new node in this linked list, and the new node should always be added from the top at the beginning of the linked list. And suppose the address of this node is 1009, so top should store the address of this node, and each node should store the address of its next node. Now suppose this node is storing 75 as an element, so you can imagine this whole thing as three elements in the stack and the new element added from the top. So always add a new node at the beginning of the linked list, and in case of deletion, always delete a node from the top, which means always delete a node at the beginning of the linked list. So the first node should always get deleted. So if I perform deletion, then this first node should get deleted, and imagine this as one element from the stack getting deleted from the top. Now this node has been deleted from the linked list, and this node is now the first node in this list, so top should store the address of this node. Now again, if I want to delete another element from the stack, then this first node, which is at the beginning of the list, should get deleted, and imagine this as one element from the stack getting deleted from the top. So this node has been deleted from the linked list, and now this is the first node in this list, so top should store the address of this node. Now if I delete this node also, then the last element in the stack will get deleted. Stack will become empty, and in that case, top will be equal to null. So this was the concept. So to implement stack using a linked list, always insert and delete nodes at the beginning of the linked list. And now I am going to show you how to create a program on stacks using a linked list. Now my previous tutorials were about linked lists, and if you know this much, then you can easily create this program. And this is a very easy program because it only requires you to add and delete nodes from the beginning of the list, because beginning of the list means top of the stack. Now this is a program on how to implement stack using a linked list. And in the video description there is a link, and if you follow that link you will find all this code. Now this is the structure of the node, the info part of the node and the link part of the node. We need three functions, so we have declared them here. Function push to insert a node at the beginning of the linked list or insert elements into the stack. Function pop to delete a node from the beginning of the linked list or delete elements from the stack, and function display. Now the beginning of the linked list is the top end of the stack, and you know that elements in the stack are always inserted and deleted from the top end. This is why we need functions which can add and delete nodes at the beginning of the linked list. Now, the top here is declared in the global section. This top is a pointer variable that stores the address of the first node in the list. Top stores the address of the first node in the list, and when the list is empty, then the value of top is equal to null, and initially the linked list should be empty. So we initialize top equals to null. Now every pointer variable has its own data type. It could be int, float, etc. So this pointer variable top is of type struct node. Now there's a rule: if you create a new variable in this section just before the semicolon of this structure, then you don't need to mention its data type. So if you don't like this, then this is the same thing. Pointer top of type struct node declared and initialized in the global section of the program. This is the same thing. This is the main function of the program, and there is not much to explain in this. These printf statements displays the choices that the user has, one for push, two for pop, and so on. And based on the choice entered by the user with the help of this scanf statement, an appropriate choice is executed and a function is called. This is the push function call, this is the pop function call, and this is the display function call. Now this push function is used to insert elements into the stack, and an element can be an integer value, float value, character, etc. whatever is declared in this section, and in this program it's integer value. Now when we implement stack using an array, then we have to create an array. And here we are implementing or creating a stack using a linked list. So here we have to create a linked list. And A linked list consists of nodes, and each node has its own address. Each node in the linked list has a memory address, and that address can be any combination of numbers. So here we are dealing with memory address, and a pointer can be used to store address. So we declare a pointer variable of type struct node named temp. Now with the help of this malloc function, a new node will be created. And if you want to know more about this malloc function, then you can follow the link in the video description. Now here what you need to understand is that this is the syntax of this malloc function: data type, name of the function, data type, and the data type in this program is struct node. Now this size of tells this malloc function that how much memory should be allocated, and it depends on the data type because each data type needs a specific amount of memory to store information. For example, an int or integer value generally takes 4 bytes of space to store information. So it depends on the data type that how much memory will be allocated with the help of this malloc function. Suppose this is the memory, and with the help of the malloc function, this part of the memory is allocated for the new node, and each memory location has an address. So malloc returns the address of the allocated memory, which becomes the new node, and that address can be assigned to a pointer variable, which is temp here. So temp stores the address of the new node that is created. So always remember that temp means the new node. This is the stack overflow condition when the stack is full. Now if there is no memory left to be allocated, for example, your computer runs out of memory and there is no memory left to be allocated for the new node, then in that case, malloc returns null, and null will be assigned to temp, and if temp equals to null, then stack overflow will be printed, and with the help of this return statement, the program control will come out of this push function. Now usually this if condition will be false, and if this if condition is false, then these three statements will get executed. Now I am going to explain you these three statements, and these two statements here are responsible for placing the node at the beginning of the list. Now initially the value of top is equal to null, and when top is equal to null, then it means that the linked list is empty. So initially at the start the linked list will always be empty. If the push function gets called, then it will be called with the number the user wants to insert. Now temp means the new node which is created, and temp arrow operator info means info part of the new node. So whatever the value of num entered by the user will get stored in the info part of the new node. Temp arrow operator link means link part of the new node, which is assigned the value of top, and the value of top is still equal to null. The value of top here is still equal to null. So null is assigned to link part of this node, and rightly so, because this is the last node in the list, and the last node, the link part of the last node should always be null. Because this is the only node in the list, this is also the first node in the list, and top should always store the address of the first node if the list is not empty. Now top is assigned the value of temp, which is the address of the new node. So top now stores the address of the first node. So top points to the first node. Now if again this push function gets called, then it will be called with the number which the user wants to insert. A new node will be created, and suppose this is the new node which is created with the help of the malloc function, then temp arrow operator info means info part of this node, and suppose the value of num entered by the user is 60. Now we need to add a new node at the beginning of the linked list. So this node should become the first node in this list, and this node should be the second node in the list. So the link part of this node should store the address of this node. Now temp arrow operator link means link part of this node, which is assigned the value of top, and the value of top is the address of this node. So the address of this node, which is 1001, will be assigned to the link part of this node. Top should always store the address of the first node in the list, and when a new node is added at the beginning of the list, then that node becomes the first node. So the value of top needs to be updated, and top is assigned the value of temp, and the value of temp is the address of the new node which becomes the first node. So top now stores the address of the first node in the list. So this was the push function to insert elements into the stack, and this linked list represents a stack with two elements, 15 and 60. Now the pop function to delete a node at the beginning of the linked list from the top end, which means deleting an element from the top end of the stack. Now this temp and this one, they are both different. This temp is a local variable of the function push, and this one is a local variable of the function pop. Now if the stack is empty, then you cannot delete anything from the stack, and in this case the stack is empty when there are no nodes in the linked list. So when top is equal to null, then it means list is empty. So if top is equal to null, then print stack underflow, which means stack is empty, and with the help of this return statement, the control will move out of this pop function. So if the pop function gets called, and if this if condition is false, if the stack is not empty, then all this code will get executed and the first node will get deleted, which is deleting an element from the top end of the stack. Temp is a pointer variable which is declared here, and temp is assigned the value of top, and the value of top is the address of the first node, because top stores the address of the first node, and this first node is the node which is going to get deleted. So temp means the node which will get deleted. Num is the actual information. It is the number which will get deleted from the stack, because top means the first node, because top stores the address of the first node. So top arrow operator info means info part of this node, which is 60 in this example. It is assigned to this variable num. If this node is removed from the list, then this node will become the first node in the list, and top should store the address of this node. So the value of top needs to be changed. Now top always means the first node. In this example, top is 1005. So top arrow operator link means link part of the first node, and the link part of this node stores the address of the next node, which is 1001. So the address of the next node is assigned to top. So now top stores the address of this node, and this node is removed from this list. Now this is the state of the stack. 60 is removed from the top. Free is a function, and any memory which is allocated by using the malloc function can be freed by using the free function. Temp stores the address of the node to be removed. Now this statement removes the first node only from the list, not from the memory. Somewhere in the memory, that removed node still occupies some space, which can be freed by using the free function. This printf statement just prints the element or the number that just got deleted from the stack. In this example, it is 60. Return num because this pop function is not of type void, it is of type int, so we must return some integer value. If again this pop function gets called, then this node will get deleted and the stack will become empty. Now here temp is storing the address of this node which is going to get deleted. Num is 15. Top arrow operator link means link part of the first node, which is this, and it is equal to null, so null will be assigned to top. So now top will be equal to null, the list is empty and this node is removed from this list. Free temp will free the memory occupied by the node that just got removed from the list. Now if again this pop function gets called, then this if condition will become true because top is equal to null, the list is empty. So stack underflow will be printed, which means the stack is empty. So this was the pop function to delete elements from the stack. Now the display function to display or print the elements. For example, in this case, the display function should print 60 and 15. Now if the display function gets called and if top is equal to null, which means if the stack is empty, then stack underflow should be printed. And with the help of this return statement, the program control should move out of this display function. If this if condition is false, if the stack is not empty, then all these statements will get executed. P is a pointer variable of type struct node and P is assigned the value of top and the value of top is the address of the first node. So P is storing the address of the first node. This while loop means that as long as the value of P is not equal to null, then keep on executing this loop, these two statements. Now P arrow operator info means info part of this node, which is 60. So this printf statement should print 60. Now this statement will move P to the next node because P arrow operator link means link part of this node and the link part of each node has the address of its next node. So the address of the next node will be assigned to P. Now P stores the address of this node. The second time this while loop is checked, P is not equal to null. This condition is true because according to this example, the value of P is the address of this node, which is 1001. It is not equal to null. And this printf statement will print the info part of this node, which is 15. This statement will again change the value of P because P arrow operator link means link part of this node, which is null. So null will be assigned to P. Now P is equal to null. So the third time this while condition is checked, P will be equal to null and this condition will become false. So the program control will move out of this while loop. So this is the end of this program. These printf statements displays the user the choices push, pop, display and exit. This printf statement allows me to enter a choice. I choose 1 to insert an element into the stack, and based on the choice, this case 1 is executed. This scanf statement allows me to enter a number which I want to insert into the stack. Then this push function gets called with the number that I just entered, and after executing this push function, the control returns to this break statement. And because of this break statement, the program control moves out of this switch statement, and this is where this while one loop comes into play. This while one loop is an infinite loop, so it again executes all these printf statements, as you can see here: push, pop, display and exit. So it doesn't allow the program to terminate after running once. So this is the end of this program. These printf statements displays the choices to the user: push, pop, display and exit. This scanf statement allows me to enter a choice. I choose 1 to insert an element into the stack. Based on the choice, this case 1 gets executed. This scanf statement allows me to enter a number which I want to insert into the stack. Then this push function gets called with the number that I just entered. And after execution of this push function, the control moves to this break statement, and because of this break statement, the control moves out of this switch statement, and this is where this while one loop comes into play. This while one loop is an infinite loop, so it again executes all these printf statements, as you can see here: push, pop, display and exit the second time. So this while one loop doesn't allow the program to terminate on its own after running once. Now the stack has 4 elements: 10, 20, 30 and 40. Now I choose 3 to display. This display function gets called, and the elements in the stack gets displayed: 10, 20, 30 and 40. First 10 was added, then 20 was added from the top, then 30 was added from the top, and then 40 was added from the top. Now I choose 2 to delete an element from the stack. So 40 should get deleted from the top end of the stack, and 40 is deleted. The next time 30 should get deleted. You can follow the link in the video description below and you will get all this code. So this is the end of this video tutorial, and thanks for watching.